neatly with the timing, especially timing, okay? So I will be presenting our first presenter, our keynote speaker. She is Barbara Oakley. She's visiting us from the United States. And I will be briefly explanation out here. She has a degree in Slavic languages and also later obtained her electrical engineering degree, and also have masters in electrical engineering and computing, and afterwards she obtained her PhD in systems engineering. So we have some very interesting topics, and today we will be having her presentation titled Detective Learning in Science and Mathematically Based Subjects like Bioengineering. So please receive her to the talk.
It's such an honor for me to be here. This conference is so impressive. It has attracted international attention. And so I want to especially I'd like to invite Karina, Enrique, Jaime, and the rest of the organizing committee. This is a conference by students, for students, as Christopher James, the International Student Conference Chair, often likes to say, and you've done a phenomenal job here, and so you're part of a community that's extraordinary. So it's exciting for me to be here, and I'd like to begin by telling you a little bit about, well, I have this background where I traveled a lot. I did lots of different jobs around the world. And I love to watch people, just love to watch them. So I have to tell you a story about the most interesting person I've ever watched. This person could mimic almost anyone. He could imitate and do the same voice as anybody. And he was just a little guy, had a big head, so he looked like an upside-down exclamation point. And what he liked to do, his name was Neil. And he had a little voice, but he would do an imitation of this man named Art Brown, who was this big man, very, very tall gorilla, right? So Neil liked to pick up the phone and say, "Hello, this is Art Brown speaking," in a perfect imitation of Art Brown's voice. So one day, he picked up the phone with me and he picks it up and says, "Hello, this is Art Brown speaking." And it was Art Brown on the other end of the phone. So Art Brown says, "Who the hell is this?" Which kind of means, who is this? In the right sense. And Neil answers, "Why, Art, this is you. I'm so glad you've finally gotten in touch with yourself." So that's actually what we're going to be doing here today. We're going to be allowing you to get in touch with yourself and some of your motivations and ideas about how you learn things. Now, to begin with, I want to tell you just a little bit more about my own background. So I grew up, and actually, I stayed in the United States when I was a little girl, but I moved all over the place. So by the time I was in 10th grade, I lived in 10 different places. Now, you probably know that mathematics is very logical and very sequential. And so what that meant was when I was moving, sometimes they were further ahead than I was, and I couldn't understand. I got lost with mathematics. I hated mathematics. I really hated mathematics. And I flunked. I did very, very badly all through elementary school, middle school, and high school. And so it's kind of funny to say that now because I'm standing in front of you as a professor of engineering, and I've published in some of the top journals in the world, done very, very well as a professor. So one day, one of my students asked me, he found out about my horrible past, which I ordinarily kept hidden. And he asked me, how did you do it? How did you change from being a non-science, non-mathematical person to becoming very good at being math and science? And I thought, you know, that's funny. How did I do it? And so I thought about it, and I remembered when I was a little girl, I just loved language and animals, and I loved knitting. I mean, it was just the classic, you know, little girl. And I wanted to grow up and study a language. And so, and I should have picked Spanish, darn it. You know, that's the best, right? But it's in my family. I have to proudly say that our son-in-law is from Chile. So our daughter speaks Spanish very fluently, and she speaks the right Spanish because it's Chilean Spanish. So anyway, I chose a language, and randomly I chose to speak Russian. And there was only one way that you could learn a language and get paid to learn a language. And that was to join the army. So I joined the army, and that's me. I'm looking very nervous about to throw a hand grenade, right? Because I'm very clumsy, so of course I'm really nervous. And I learned Russian, and I ended up working as a Russian translator on Soviet trawlers up in the Bering Sea. And I loved adventure and looking at things from new perspectives. So I also ended up working at the South Pole Station. It's a little dark image here, but that's actually me at the South Pole in Antarctica. And that's where I met my husband. So I always say I had to go to the end of the earth to meet that man. But what I began to realize was that when I was having these adventures and these new perspectives, that I actually wasn't really doing something really new. I mean, I was just following my passions, but I wasn't doing something different than my passions, right? So I thought about it, and when I was in the military, I worked with all these engineers, and they could understand this incredible mathematics. I'd look at their books and I'd be like, oh my goodness. But then I thought, what if I could understand some of that language, right? It's a new language. If I'm so excited about new perspectives, why don't I try this new perspective? And so I decided to retrain my brain. So I was 26 years old, and I got out of the military, and I began to study engineering. And at that time, it was very, very difficult. I made every mistake in learning that you possibly could make. If I knew then what I now know about how to learn more easily and effectively, I could have made my job much easier. And so, as I began thinking about how did I change my brain, was trying to answer that student's question. So I love to write, and one of the things I did was I started working on a manuscript, a book, to describe what we know about how to learn most effectively. And I reached out, here's what I did. Do you have this thing called, or something that's called Rate My Professors? Maybe you don't have it. And it allows you to see how good professors are and how much students like them. So I went and I found the top 200 or 300 professors on Rate My Professors in engineering, mathematics, physics, all the really difficult disciplines. And I wrote them. And I said, would you look at my manuscript and tell me what you think about how you teach most effectively so that people can really learn most effectively. And what I found was, it was like this secret handshake. All the top professors used these sort of common ways of teaching and learning, but other professors didn't use these approaches. So some of these approaches that are the top ways of looking at how to learn are what I'm going to tell you today. And I'm also going to give you some insight into what top researchers have to say about teaching and learning in the most effective way. And all of this eventually became both the mind of the numbers, and I'm happy to say it became a New York Times bestseller. So I was really surprised at that. But if you're interested, there's an inexpensive, in fact, a totally free way to look at many of the key ideas in the book, and that is to go to this course right here, which is a massive open online course, and you will see videos of me discussing many of these ideas. It's all free. So my husband and I spent the last summer just going through and creating these things. So with that, what I want to tell you now are some of the key ideas about how to learn most effectively. So we know that the brain is enormously complex, but because we're engineers, we can simplify the brain's operation into two fundamentally different modes. The first is what I'll call focus mode. And focus mode, you will be questioned on this, so pay attention. Focus mode is when you're focusing in, you're actually paying attention. And the other mode is what I call the diffuse mode. And it's actually a set of neural resting states. So one is when you're focusing really hard, the other when you're not thinking about anything in particular. And there's actually wonderful research on this neural resting states of the diffuse mode. And this was initially discovered about 15 years ago by Marcus Raichle at Washington University. So at any rate, to understand how to better conceptualize what these two different modes of learning are, we're going to use metaphor, right, and analogy, because they make it more interesting, but also allow you to learn more easily. So our first metaphor, to help us understand the differences in these modes, is a pinball machine. And everybody probably has seen a pinball machine as you're really young. You pull back on the plunger, a ball goes bouncing around on the rubber bumpers, and that's how you get points. So what we're going to do is we're going to take that pinball. We're going to actually see some zombies here too. I like zombies, so we're going to take that pinball machine and we're going to put it onto a brain. And you can see here's the ears and the nose is up at the top. And so now watch it. We're going to put that pinball machine right there on the brain. And now you can see, look at these rubber bumpers. This is symbolic of the focus mode of thinking. And rubber bumpers are very close together. So often in the focus mode, you're thinking about a thought you're kind of familiar with. Like let's say that you're doing a multiplication problem. You're probably familiar with multiplication. There's like pathways that are already there. And that's symbolized by that orange pathway there. And so when you think a thought, it moves along and it moves smoothly along the pathways that are already there. So but there's a problem. What if you are trying to think a thought about a concept that you've never really thought about? Like let's say you're trying to understand the concept of limits in calculus. That could be a very new concept. So it's almost as if it's a pattern that hasn't yet been formed in your brain. You don't know how to get to that as it works out. Your brain uses a very different mode of thinking, and that mode is the diffuse mode. Now watch what happens. When you are thinking in this mode, your thoughts can range much more widely. See how far apart those rubber bumpers are? And so that allows you to range much more widely than you can think the careful, focused thoughts you can when you're in the focus mode, but you can at least get to the part of the brain where you can start thinking about something new because you're able to range much more widely. Now, it turns out that you can either be in the focus mode or you can be in the diffuse mode. You can't be in both at the same time. So what this means is when you're trying to learn something new and you get stuck, the worst thing you can do is just to keep thinking about it, right? Because you have to get your attention off it in order to allow this mode of thinking to take place. Now, I know what you're probably thinking is, okay, well, this sounds great theoretically, but what does this have to do with real life? If you look at this guy right here, he was an incredibly famous surrealist painter in the 20th century, and his name was Salvador Dali. And Salvador Dali was the original wild and crazy guy. You can see he's there with his pet ocelot, Babu. And what Dali used to do, when he was trying to figure out a problem related to his art, he would sit in a chair with a key in his hand. And he'd relax, loosely thinking about whatever problem he was trying to solve. And he'd relax away, relax, until he relaxed so much the key would fall from his hand. And so the clatter, the noise, would wake him up. And he'd wake up and take the ideas from the diffuse mode and bring them back into the focus mode where he could concentrate and actually make them happen. So there is a way to use these different brain modalities, different brain modes, to think about and solve creative problems. But I know what you're all thinking. You're thinking, oh, we're engineers. Who cares about these artist types? Well, if you look at this guy here, he was Thomas Edison, one of the most brilliant inventors in history. And what Thomas Edison used to do, as it turns out, at least according to legend, he would sit in a chair with ball bearings in his hand. He'd relax away, relax, thinking about a problem, a tactical problem he was trying to solve. And just as he relaxed so much that he'd fall asleep, the ball bearings would fall from his hand, wake him up, and he'd take those ideas from the diffuse mode back into the focus mode where he could work and refine. So the lesson for us in all of this is when you are working on an engineering problem, and you're thinking, maybe this is a problem that lots of other people have solved. It doesn't matter. For you, you are being just as creative in your problem solving as Salvador Dali and Thomas Edison were doing. And so for you, you want to use some of these different creative abilities of the brain in both focusing and relaxing, stepping away from what you're trying to learn about, particularly when you get stuck. So I just want to give you a little picture here. This image shows different views. These are major portions of the brain, and these are some of the connections that you have when you're in resting states, right? Neural resting states, relaxing. Look at all these web of connections. Those connections many of them are not there when you're focusing. So when you're focusing, you're in some sense blocking these other kinds of connections. This is why it can be very important to focus and then relax in order to learn. Now, it takes time for this to take place, right? You can't just sit down and think you're going to solve a problem, get stuck, relax, let it come to you. Often that doesn't work. You have to get your mind off it, it takes sometimes several hours. So this is why it can be important to try, go to sleep, wake up again, and then it can be fresh. In some sense, what you're really doing is this. It's kind of like a weightlifter. Would a weightlifter ever sit there and cram the night before a big meet and think that he could build these kinds of muscles just by working out the night before? Of course not. It takes time to build muscular structure. In the same way, you're actually building neural structure when you're learning something new. So you never want to just cram it at the last minute. You want to work a little bit every day, and we'll talk a little bit more about this. Now, what I'd like you to do now is I'd like you to take a few minutes here, and I want you to team up. You can team up with someone you know and like if you would like to, but I would be really honored and happy if you might reach out to someone new here who you don't know and partner up with them. And what I would like you to do for the next 2 minutes is I would like you to explain to one another what is the difference between focus and diffuse modes. And on your mark, get set, happy buzz of talking as you describe this. And if they work through it for about 20 minutes, the pain will gradually go away. But the second way is all you need to do is turn your attention away, and the pain will go away instantly, right? But this is called procrastination. And if you do it once, you do it twice, it's not that big a deal. You do it a lot of times, and it actually can profoundly affect your life. You can say, I can't do that subject. When the reality is you can do it, it's just you keep procrastinating. So what I'm going to do is I'm going to give you one of the best, most powerful tricks to get around procrastination. And this trick is called the Pomodoro. It was invented by, it's a technique invented by an Italian, Concepción in the 1980s. And what he did was he simply took a timer and he set a time, and he had a tomato-shaped timer. And so that's why it's called the Pomodoro technique. And he'd set it for 25 minutes, and then he would, this is what he recommends. You set it for 25 minutes, you turn off any other things that might distract you. So no text messages, no cell phones, no bouncing television going on in the background. All distractions go away. And for 25 minutes, you focus as intently as you can. Now, if you're like me, sometimes what I'll do, I do Pomodoros, right? So I'll turn on the Pomodoro timer, and I'll be looking at it, and then I'm going, but I'm thinking about whether I'm working as intently as I can. So does that mean I'm really working as intently as I can? Because I'm not actually thinking about what I'm supposed to be doing. So I get myself confused. So, but then I say, put that aside and just work as smoothly and intently as you can. And anybody can work for 25 minutes with careful, focused attention. Then when you're done, relax, right? Take a few minutes or many minutes, whatever you feel comfortable with. And now you're beginning to understand this stepping back and relaxing is also a very important part of learning. And so you want to focus and then practice relaxing. And between the two of those things, it can really help build your understanding. And what this does, this is a trick. Remember when I said when you look at something, the pain centers of your brain activate? Well, if you focus on the Pomodoro, and then just say, I'm going to focus intently, but not think about what you're really focusing on, what that task is, you don't activate the pain centers. You just slip into the work and get that done with much less pain. The last thing that you want to do, you never want to sit there and go, I'm going to be so tough. I'm going to use willpower to get these, to learn this stuff. And I'm going to make a 25-minute Pomodoro, and I'm really going to, you don't want to waste willpower that way. Willpower is very expensive, right, metabolically. So just by saying, I'm going to set the time, and then I'll just kind of do what I'll focus, but not think about, I've got to use a lot of willpower. You'll find that it's much easier. Only use willpower very occasionally when you actually need to keep yourself started in something. Now, just a little side note is, don't sit down and think, I'm going to finish all of my homework in 25 minutes, right, or something like that. Don't focus on finishing a task. Just focus on doing the best you can for those 25 minutes. And the other thing is, make little changes. Don't sit there and think, I'm going to do 10 Pomodoros today, and that will solve all my problems. Just make little adjustments in your life. Try this technique, and you'll gradually see it makes a difference. So I'm now going to switch to a different topic, and this is the importance of sleep. Have any of you ever gone through a night to take a test, and then you studied really hard all night long, took a test the next morning with no sleep? Has anybody ever done that here? A few people. I want to tell you just a little bit about sleep. Latest research, often done by bioengineers, and because of the breakthroughs that bioengineers have given. What we now know is, in your brain, you have cells, of course, you've got your neurons, and what happens is when you're thinking and awake during the day, there are metabolites that come out of your cells. They come out, and then what happens is they sit there, and they're like poison in your brain. But when you go to sleep at night, your brain cells shrink. So watch this. Watch how the cells will shrink. See, you go to sleep, and your brain cells shrink. And what that allows, you're engineers now, so you understand a little bit about fluid flow. And that allows more easily fluid to flow by and to wash those toxins away from the brain. So that's part of why sleep is so important. It helps to clean the toxins, the poisons from your brain. Now, there's another very, very important aspect of sleep, and that is this. This is an incredible view of the same neuron before learning and before sleep, and then down below is after learning and after sleep. Everywhere that you see a triangle is a new synaptic connection, right, with another neuron in the brain that has grown during the time you're sleeping. So this actually, sleep is incredibly important in helping to build the neural structure that is involved in learning something new. So again, sleep is really, really valuable. Now, I also want to touch on another important topic. We often think directly about learning and what can we do to enhance our learning. And we think of sitting and focusing and those kinds of things. But what we don't think about is the importance of other aspects of our lives on our ability to learn. It turns out that if you took there's a single thing that's like a drug for your brain that helps you to learn and remember more effectively, and that drug-like effect actually occurs because of exercise. It turns out that for example, my colleague Terry Stanowski did some of this incredible research that revealed what they did was they took a mouse and they taught that mouse to differentiate between two different patterns. So they were teaching the mouse this, and what they found is this. We used to think that new neurons, they never grew. Whatever neurons you got when you were first born, that's what you have. Now we know new neurons are being born every day in critical parts of the brain, and one of those critical parts is the hippocampus. So this mouse, for example, every day he's got those blue neurons versus the old neurons. But the red neurons are the new neurons being born every day that are helping him to understand the difference in the patterns. And so, as it turns out, there are two ways to help those new neurons to survive and grow very well. One is to get exposure to new places, right? New environments. So that's why if you have the ability to go off and study in a different country, take that opportunity. It's a new environment that will enrich how your brain works. That's what I love about coming here. It's a difference, and it's beautiful. It's wonderful. It's very enriching for me, and I want to see you have some of those kinds of same enriching experiences. But the other way that those new neurons can grow and survive is simply through. It doesn't mean you need to be a marathon runner. I go for a walk every day. Whatever you do, try to get exercise. That will, within days, make a difference in your ability to learn and to remember. So I asked my colleague, Terry Stanowski, and Terry and I did that massive open online course together. And so we were filming about learning how to run. And I asked Gary, I said, so do you do any exercise? He said, oh, do I exercise? Let me show you. And so he did. We went down, and this guy, it's amazing. He's like a mountain goat. I mean, he's 65 years old, and he's just amazing. Look at it. He goes down to the beach, he runs 5 miles every day, and that, I think, is part of why he's such a great scientist. I love how he finished. Yes. Yeah. So think about it. You often don't think about the importance of exercise in your ability to be a good student, but it's actually really important. And even top scientists take this idea to heart. So we're going to talk just a little bit about, I want to touch on the idea of working memory. Now, working memory is when you're holding a thought in mind. And working memory is in your prefrontal cortex. We used to think there were 7 things you could hold in mind at once, but now we understand that that working memory is kind of like you can have maybe 4 items that you can hold in mind at once. And so your working memory is kind of like this. When you focus your attention, it's like an octopus, and it reaches these tendrils down and makes connections in your brain. So you can only have 4 real big connections that you can make. And if you are paying attention to other things, that's what it does. It's like it blocks one of your slots of working memory, and it makes you more stupid, right? You're not using all of your full mental capacities. Now, this just gives you a little bit of a sense. This is more like a reduced mode study, very random set of connections. Now, if you want to take something in working memory and put it into long-term memory, what you want to do is practice. Practice makes permanent, right? And so you want to repeat as much as you can. So here you go. By repeating, you make these patterns deeper and richer. So if you do not practice, notice, do you have the word vampire? These little metabolic vampires will come and suck away the pattern if you don't practice it. So you can even understand something in class, get it, but if you walk away and you don't practice it, those metabolic vampires will suck away the pattern. So it's gone, and that's why you can't figure out and stay with it. So the best way to practice and to remember things is to do it day by day, right? So practice and do a little practice over the days. The thing you do not want to do is you don't want to just practice a bunch, right? Right before a big test, because then those metabolic vampires, your pattern won't be very deep, and it's easier for those patterns to slip away afterwards. Now, one way to think of it is like this. You have a brick wall, and to build a good brick wall, you lay a pattern, or lay a roll of bricks, and you let the mortar dry. Lay a roll of bricks, let it dry. And so over time, you build a solid wall. If you try and do everything at once, it creates kind of a trust, not very good at all. So just in the interest of time, we're going to skip ahead here to the very last parts of this talk. So when it comes to focusing and paying attention, we know we've got those 4 slots in working memory. And when you are trying to learn something new, it's often like trying to figure out a puzzle. And what's really happening is your working memory, that it's working really hard. In fact, studies show that when you're trying to figure out something brand new, your working memory is going crazy, prefrontal cortex. But when you figure something out, right, like you figure out what this puzzle is, hey, does that look like my husband? Yes. So you figure out what it is, it's as if you've made one nice neural connection, and it's like a ribbon that you can pull in mind easily, and you can connect it. It leaves room in your working memory for other things to bring in. So chunking, as it turns out, creating that ribbon of thought is, it's kind of like a nice ribbon, but think about it this way. If you're learning to play like the guitar, you often learn a little piece of a song, another little piece of a song, and then you connect things together, right? So you can actually make longer, bigger chunks in whatever you're doing. And what the whole goal is you want to get to create like a library of chunks that you can easily connect together as you're doing something new. Now, chunking is like this. When you're learning something new, you're trying to fit together the big picture of what you're learning. So you've got chunks like, there's a chunk of a tire right there. Oops. So there's your tire, and there's the face, and there's another tire. These are like chunks. And what happens is you want to fit together all these different chunks so you've got the big picture of the topic. But if you don't practice with your chunks, it's like you're trying to fit together something that's very faint, and it's really, really hard to do. So again, when you're learning something new, you want to create a nice chunk of whatever you're learning. And surprisingly, this can relate, sometimes a chunk in one area can help you see the patterns that are similar in very different. This is called transfer. So, just to touch a little bit, sometimes what we think are our worst aspects are actually our best aspects. If you worry that you have a poor memory, guess what? It means you have to work harder in order to learn something. But it also means that you are more creative. Your 4 slots of working memory, other things can get in. You can't hold things as tightly, but that allows other things to come in, and that's why you're more creative. So yeah, you have to work harder, but the trade-offs can make it worth it. Also, sometimes people think, I'm a really slow thinker. You know, I can't compete with these brilliant people who can think so much faster. Well, I want to tell you about Miriam Mirzakhani, who was told that she could not study mathematics because she was such a slow thinker. And it turns out she just won the top award in mathematics for her great creative abilities. So just because you may think more slowly, that is not necessarily a disadvantage, because sometimes you can think more deeply about what you want to learn. So there is something called the imposter syndrome. Has anyone here ever felt like I'm here, like I'm fooling other people, I'm actually not as good as people say? Has anyone ever had that? I have that feeling. But a lot of times people do not want to admit this. And so this is so common that this syndrome actually has a name, and it's called the imposter syndrome. So quickly going through, I just want to give you illusions and an idea of the illusions of competence in math. Often we think we're really scared, like when we're taking a test, right? And so we'll panic. And it's just the feeling that, you know, it's like the scary bear just walked into a room and panicked. And it must be something physiologically wrong with us. But actually, it isn't. It's often that we have this panic feeling because we haven't prepared properly. And we're finally finding that out when we're looking at the test. So the best things you can do to prepare properly, test yourself all the time. Flashcards, in fact, are really helpful, even in math and science. They can help you to grasp the key ideas and to look at them in different ways. And homework. When you do homework, never just work a problem and put it away. I mean, would you practice a song by playing it one time and then saying, I've got it, and that's enough? You want to look at homework problems and see if you can work them in your mind so that, like a song, they can play through rapidly, really know it, so you can quickly solve problems. Recall. Turns way that you can solve problems or understand a new concept is to look at a page that you're trying to learn, look away, and see if you can recall the main ideas of the page. Don't highlight, don't mark it all up. You can make a little mark, you can mark on the margins, but don't just reread and highlight them. Recall, look away and see if you can recall. And lastly, study judiciously what team is. That can help expose errors in your own. You can explain, a good thing to do always is to just explain like that so a 10-year-old can understand. And top researchers in the world often use this precise thing. So try to explain simply. And surprisingly, just like electricity, you can say, it's like water. That's a good analogy, and it really helps explain this or that particular concept. And also, try to put yourself in whatever you're doing now. Right? Try to imagine. If you're thinking about copper atoms, try to imagine yourself down in that world of copper atoms, and that can help you understand more easily the kind of things that you're doing. In closing, I would like to relate this idea. Passion is, do you have this expression in Spanish? A double-edged sword, right? So it has two aspects. Passion can be a wonderful thing. And we often say, follow your passion. But passion develops about what we're really good at. And some things take longer to get good at. So don't just follow your passions. Broaden your passions. Be willing to pursue even something that's more difficult because it can be even more rewarding when you actually learn it. And with that, I thank you so very much for being here.
So thank you very much for the talk. So now, if any one of the audience would have some time for questions.
Did I intimidate you all with my too fast English? I hope not. Is this relevant to what you're learning about at the university here? A little bit? A lot? Did I put you to sleep? So does someone have a question here that, about anything that we talked about? Yes, I know you look like
So, anyone have any questions?
And if you make mistakes in your English, I am very forgiving. Because it's much better than my Spanish.
All of these are like techniques, so I can use it to learn or make video. Can you use these from the other side, from the teacher side?
Yes. From a teacher side, a big thing that this kind of thing brings out is test your students all the time. So every time you meet, give a test. If there's a way that you can maybe sometimes exchange tests to have them help grade, that can be a beneficial thing too. But more often, and then set things up so that the students don't have a big project, after a bunch of weeks. But small points to help them to prevent procrastination. Actually discuss procrastination in class. And bring out these ideas. You can do it in just a minute or two. That procrastination is really a big deal, and they want to. Your students should try to minimize them, or just get a few techniques in place to start addressing procrastination. So these are some of the ways that you can start using some of these ideas in helping, and then try to always bring out the idea of challenge. To practice so that they really have the ideas integrated and they can put them students often think if they just understand it, that's enough. And that's not enough at all, because because the metabolic vampires really sucks in the language. So anything more? With that, I thank you so much again. It's an honor to be.
So, Barbara, once again, we all thank you for the amazing talk. And now, Karina, that will give you some questions.